In this video, I am simply going to work through the questions one at a time on the November 2018 Pearson Edexcel Foundation Maths Paper 1. So, question 1. Write the following numbers in order of size, and we start with the smallest number. I think if you are not sure, a good way to approach this is to write the numbers in a column. So we have 0.4, 0.02, we have 0.37, we have 0.152 and 0.2. Now the trick here is to look at each column starting on the left hand side. Now of course all these numbers are all zero, so we cannot compare the size by looking at the whole number. So we move to the next column. We have 40312. The lowest number in this column is the 0. It does not matter what follows in the smaller columns. Therefore, if that is 1, we have 0.02 as the smallest number. We then continue in the same manner. The next number is a 1. We've discounted the 0. We now have a 1 here. So that's the second largest number. So 0.152. That takes care of that one. We have a 2, a 3 and a 4. So they're going to be listed in that order. We have 0.2. Then 0.37. And then 0.4. Question 2 asks us to write 0.6 as a percentage. The simplest way is to take a decimal, any decimal at all, and if we multiply by 100, the answer we get is 60. Therefore, the answer is 60%. Moving on to question 3, it says here there's a list of numbers, and there we have a list. It says from the list write down a factor of 10. Well, a factor is a number that divides exactly into another number. So the factors of 10 are any number that you can divide it by. And in this list, the only number that divides exactly into 10 is 5. So 5 is the answer. 3, 2, 1. Question 4 simply says write 7829 to the nearest thousand. So we have the number 7829. We know that we have units, tens, hundreds and thousands. So the 7 is the thousand. If we are going to write it to the nearest thousand, we have to look at the number that is next to the thousand column. In this case, the 8. Because the 8 is 5 or above, we use the rule that therefore rounds up the 7. So to the nearest thousand, we have 8,000. 3, 2, 1. Question 5 has 3 parts. So 5a is work out 3 times 5 plus 7. This is asking us to apply BIDMAS to make sure that we know what order to perform the different operations. In this case, with BIDMAS, multiply comes before plus. So we would do the 3 times 5 first is 15 and then add on the 7. So our answer is 22. Part B is work out 2 to the power 3 or 2 cubed. That simply tells us how many times we are multiplying 2 by itself. The 3 tells us it's 3 times, so we are looking at 2 times 2 times 2, and the answer is 8. We're now being asked to add a pair of brackets in this statement to make it correct. Now if we look at the statement as it is, we have 7 times 2, that is 14, plus 3 would be 17, so that's not the correct answer. Again, we are applying BIDMAS, but if we put a pair of brackets around the 2 and the 3, again using BIDMAS, B for brackets, it means we have to sort out the brackets first, so we add the 2 numbers in the brackets together. That becomes 5, 2 plus 3, so we are now left with 7 times 5, and that indeed does make 35, so our brackets are in the right place. Question 6. Sue has 2 cats. Each cat eats 1/4 of a tin of cat food each day. She buys 8 tins of cat food, and we're being asked, has Sue bought enough cat food to feed her 2 cats for 14 days? And it says you must show how you get your answer. There are 3 marks, so they are looking for working out here. There are a couple of different directions you can take with this question, but let's start from the beginning. She has 2 cats. Each cat eats 1/4 of a tin a day. So 2 times 1/4 is 1/2. So we have half a tin per day in total. Moving on from there, this means that if half a tin is a day, it therefore means 1 tin will last 2 days. If 1 tin is 2 days and she has 8 tins, therefore 8 tins would last 16 days. So in fact she has enough food for 16 days, therefore the answer they are looking for is yes. Question 7. There are only apple trees, cherry trees, pear trees and plum trees in an orchard. The pictogram shows information about the number of apple, cherry and pear trees. There's a total of 30 trees and we have to complete the pictogram. So in other words, we are being told in a pictogram how many apple, cherry and pear. We know there are 30, therefore there must be some plum trees and we need to represent that. So let's have a look at the pictogram and more importantly the key. So we are told that one of these large squares represents 4 trees. So if we look at the number of apple trees, there are 4 here and another 4 and another 4. So apple trees in total we have 12. Now the cherry tree we have 4 again, but this small square we can see it's only halfway down the large square and also halfway across. In fact it's a quarter of the large square. So a quarter of 4 is just 1. So we have 4 plus 1, we have a total of 5 cherry trees. Now pear trees, again we have 4 here, but at the side of the 4 we have a shape which is clearly a half of a full square. So a half of 4 is 2. So 4 plus 2, we have 6. Now if we add these together, we have a total of 23 trees. Now we know that the total including the plum is 30, therefore we need to represent the difference between these two, the other 7 trees. They have to be the plum trees. So we need to represent 7. Well, first of all we can do that by inserting a large square. That represents 4. We now need to put in the other 3. Slightly trickier, we know what 1 looks like, we know what 2 looks like. Well, 3 is going to be 3/4 of a large square. So in other words, I'm only doing it freehand here, but it's going to look like that. 1, 2, 3, 3/4 of a square. And that's your answer, a square representing 4 and 3/4 of a square representing 3. That adds up to 7. The total is now 30. And question 8 takes us into the world of graphs. So 8a, we have write down the coordinates of point A. Point A is here. Don't forget when we're looking at coordinates, we go along the x-axis and then y. So along the x-axis we are moving to -2. So that is your first coordinate. On the y-axis we are down here at -1. So the coordinate of A is -2, -1. We're then asked to mark on the grid with another cross the point 2, 3. So again, x first, we go to 2, and then y, we move up to 3, and we put our x on 2, 3, and it tells us to label that point B. Part C, on the grid, draw the line with the equation x equals -4. If you're not sure, then write down some coordinates where x is -4. Don't forget the x and y coordinates are side by side here. X is minus 4, so one possible answer will be minus 4, 3. You might have minus 4, 1. Should be putting brackets around these. You might have minus 4, minus 2. Let's have a look at all these coordinates. They are all points where x is minus 4. So minus 4, 3 would be here. Minus 4, 1 would be here. Minus 4, minus 2 would be here. And we can see clearly that we are creating a line where all the coordinates have a value for x of minus 4. So your line is straight down the graph like so. For question 9, we are being given the value of two letters. So we're told that G is 9 and we're told that H equals 4. So it says work out the value of 2G plus 3H. Well, 2G means 2 times G, so that is 2 times 9. And we have plus 3 times H, so that is 3 times 4. Once again, we are using BIDMAS. We know that multiply comes before add, so we are going to do the two multiplications first. So we have 2 times 9 is 18, plus 3 times 4 is 12, so 18 plus 12 is 30. Question 10 asks us to write down two prime numbers that have a sum of 32. Sum, don't forget, is addition. They add up to 32. Well, a good way is to quickly write down all the prime numbers up to the number 32. So let's have a look. The first prime number is 2, then we have 3, then 5, then 7, 11, 13, 17, 19, 23, 29, and 31. Don't forget, a prime number is a number that can only be divided by itself and 1. Now that we have the full list of all the prime numbers up to 32, we need to find out if any of them can be added together to make 32. So, for instance, one possible option would be 19 added to 13. Those two together equal 32. So two prime numbers add together to 32, 13 plus 19. There is in fact also a second option here, because you could have 29 added to 3. 3 plus 29 also make 32. So you can choose either of these two pairs of numbers. There's no magical way to find the answer to this. You simply need to write the prime numbers down and then look at some additions until you find a suitable pair of numbers. Question 11. We have a list of fractions. It tells us that one of them is not equivalent to 3/4, and we have to find out which one. Well, we don't have a calculator here, or it would be a good idea to turn them into decimals, but in fact the way we do it without a calculator is we take each of the fractions and we simplify them. So if we look at 9 and 12, they will both divide by 3. 9 divided by 3 is 3, 12 divided by 3 is 4, therefore 9 out of 12 is an equivalent. The same is true of 6 and 8. If we divide 6 and 8 both by 2, divide the top and the bottom by 2, again we will get 3/4. So that one is not our answer. 18 divided by 24, again simplifying whichever way you feel more comfortable, but in fact if you divide them both by 6, the top and the bottom, we get 3/4. Therefore it's not that one. 10/16, if we simplify that, we have to divide them both by 2 and we get 5/8. This does not simplify any further, therefore quite clearly 10/16 is not the equivalent of 3/4, so that one is our answer, 10/16. You can check the final one if you wish to do so. 15 divides by 5, 20 divides by 5, and we get again 3/4, which confirms this is our odd one out. And part B of question 11 is asking us to add two fractions together, a 12th and 5/6. Now this question is all about finding the common denominator. One common way to do this is to multiply the two denominators together to get 72. And that way works. You do have some rather large numbers. In fact, with a question like this, it's worth just taking a look at the two numbers. We have 12 and we have 6. So in fact, 12 is 2 times 6. This gives us a simpler way, because what we can do is leave 1/12 as it is, but because we have to multiply 6 by 2 to make it 12ths, then we can also multiply the 5 by 2, so 5/6 has an equivalent of 10/12. Now both fractions are in 12ths, we simply add them together and we have 11 of them, so our answer is 11/12. Question 12, we're back to graphs but of a different kind. It says Tom uses his lorry to deliver bricks. You can use this graph to find the delivery cost for different distances. Let's just take a quick look at the graph. On the bottom it tells us the distance, and up the side it tells us what the delivery cost is. So if we want to read something off the graph, for instance, if we are delivering for 40 miles, we would look up the graph to the point here and read across the cost to be £70. So let's have a look at the questions we're being asked. Part A says, how much is the fixed charge? Because for each delivery there is a fixed charge plus a charge for the distance. Well, to find the fixed charge, we look at the line, and if we come right to the beginning of the graph here, we can see that even before we have started calculating the distance, there is a cost here of £10. So even at 0 distance, there is a charge of 10. So all prices start with this £10 added on at the beginning. Therefore, that is the fixed charge of £10. Now the second part of the question says that Tom makes 2 deliveries of bricks. The distance of one delivery is 20 miles more than the distance of the other, and we work out the difference between the costs. Okay, we don't know the distance of the 2 deliveries, but we do know they are 20 miles apart. So the simplest way is to pick 2 nice easy distances on the map. So let's say that delivery 1 was 20 miles away. That means delivery 2, 20 miles further, is 40 miles away. If we read the 2 prices of these deliveries, we can see that one lands here and is therefore £40 for 20 miles, whereas for 40 miles the graph takes us up to here, and if we read across this line we are at £70. So the distance 20 miles £40, 40 miles £70. The difference between the 2 prices is our answer. It is £30. Question 13. Asmol, Ryan and Kim each played a game. Asmol's score was 4 times Ryan's score, and Kim's score was half of Asmol's score, and we need to write down the ratio of Asmol to Ryan to Kim. It's important that when we're writing the ratio down we put it in this order, so let's put their initials to start with. We have Asmol, we have Ryan, and we have Kim. Now, the first line we're told that Asmol's score was 4 times Ryan's score. Let's just assume for a moment that Ryan scored 1. If Ryan scored 1 and Asmol scored 4 times that, then Asmol's score was 4. Now look at the next line. Kim's score was half of Asmol's score. So if Asmol scored 4, Kim scored half of that, therefore Kim scored 2. And that is the ratio of their scores, 4 to 1 to 2. Question 14. The diagram shows a quadrilateral ABCD with each of its sides extended. AB equals AD. We know that because of the 2 little lines there anyway. It asks us to show that ABCD is a kite, and we have to give a reason. So here we are looking at angle laws. Okay, for it to be a kite, then we know that angle ABC, the angle here, and angle ADC have to be the same. We need to prove that they are. There is often more than one route you can take to prove a question like this, but let's have a look at what we already know about this quadrilateral. We have an angle here at the bottom, BAD is 100 degrees. The easiest angle to find is probably this one here, angle BCD, because we know it is a vertically opposite angle to the one we have here, which is 50 degrees. So we can use that rule. The reason that we give, we will say that angle BCD is equal to 50 degrees because then we have to write out the angle law. This is important to get full marks. And the angle law in this case is that opposite angles are equal. And in fact, to give them their full name, they are actually called vertically opposite angles are equal. So now that gives us the right, because we've quoted the law, to fill in 50 here. The other angle that we can now calculate is ADC, the angle here. So we can say that angle ADC, so let's write that down because we need another law, ADC is equal to. Now the law we're going to use here is that angles on a straight line add up to 180 degrees. We already know that this part of the angle is 75, therefore 180 minus 75 is 105 degrees. And again, we have to say because. And we quote the law that we know. Angles on a straight line equal 180 degrees. Now that we know this is 105, we need to prove, in order for it to be a kite, that this angle here is also 105. Now, we are looking for angle ABC. So our next line is angle ABC is equal to 105 because. Now this is the point where we get to check out our maths. The law that we're going to use is that angles inside a quadrilateral, so I have to write all that out, and it is important that you do write all these laws out. Angles inside a quadrilateral add up to or equal 360 degrees. So let's check this out. We know we have an angle of 50, we have an angle of 105, and we have an angle of 100. If we add them together, we get 255 degrees. If we take that away from 360, we get 105. So we now have proved that both these angles are 105, therefore it is a kite. Question 15. Shahid is going to use these instructions to make a fizzy drink, and he's been told to mix 5 parts of orange juice with 2 parts of lemonade. So it's a ratio question. Shahid thinks that he has 300 ml of orange juice and 200 ml of lemonade. If he's correct, we're being asked what's the greatest amount of fizzy drink he can make. Well, let's have a look at this ratio. We have got orange juice and we have got lemonade, and we know the ratio is 5 parts to 2. Now, let's assume that we are going to use all the orange juice. So that's 300 ml of orange juice. We need to look at how much lemonade we would need for that ratio. So we look at the multiples, and the question is, what is the multiple of 5 up to 300? Well, the answer, it has been multiplied by 60. If we're going to multiply orange juice by 60, we have to multiply lemonade by 60. Therefore, you would need 120 ml of lemonade. If we add these together, that means we have made 420 ml. Now, let's do this again, but use all the lemonade. So let's go back to the original ratio, orange juice to lemonade. It's 5 to 2. This time we're going to use all the lemonade, which is 200. Again, we need, therefore, to look at what the multiple is from 2 to 200. Well, this time it's been multiplied by 100. In order to make this drink, then, we would have to multiply the orange juice by 100. But unfortunately, that means we would need 500 ml of orange juice. We only have 300. Therefore, we cannot make this amount of drink. So using all the orange juice gives us the largest possible mix. Therefore, our answer is 420 millilitres. Part B. Shahid has 300 ml of orange, but he has only 160 ml of lemonade, and we've been asked, does it affect the greatest amount that he can make? And the answer, quite simply, is no. He only needs, and that's what you would write, he only needs 120 ml of lemonade to make the maximum amount. Question 16. Two rectangles, and we're given their measurements, and we're told that Jim says the two rectangles are similar because 8 plus 4 equals 12 and 6 plus 4 equals 10. We are simply being asked, is Jim correct? There's no actual maths to do here from a written point of view. We simply have to say why Jim is correct or not. And in fact, the answer would be he's incorrect, because for two shapes to be similar, then the two sets of sides have to be the same multiple of each other, not an addition. In your own words, you need to describe this. We use multiples to decide whether shapes are similar, not additions. In question 7, we have a frequency tree, and we are given a set of information. We're told 80 people are asked if they like coffee. So here's the 80 people in the circle on the left hand side. We are told 48 of these people are women. We're also told that 61 of the 80 people like coffee, and 8 of the men do not like coffee. Use this information to complete the frequency tree. So we have to use these numbers to complete the circles in the tree. Let's have a look at what we know. 80 has already been filled in for us. It is the total number of people. Out of these people, we are told that 48 are women. So we can complete this circle here. 48 of the people are women. Straight away, if there are 80 people, 48 are women, then that must mean that the other 32 are men. 32 plus 48 equals 70. Now, we are told that 8 of the men do not like coffee. This is something we can fill in straight away. From the men, 8 do not like coffee. Again, if there are 32 men and 8 of them do not like coffee, that must mean that 24 of them do. 24 plus 8 is 32 men altogether. And the last bit of information that we need to complete, 61 people liked coffee. That's in total, 61 of the 80. What do we already know? We know that out of these 61 people who like coffee, we already have shown that 24 of them are men. Therefore, if we take that away, that must mean that the number of women who like coffee must be 37, because the total number of people who like coffee, men and women together, add up to 61. We're left with just one circle incomplete. Well, there are 48 women, 37 of them like coffee, therefore 48 minus 37, 11 of them do not like coffee. That's completed the frequency tree. Now we have another question. It says one of the people who like coffee is chosen at random. Find the probability that this person is a woman. Well, we're choosing a person who likes coffee. We know that there are 61 people like coffee. So the random choice of picking this person is out of these 61 people here. We know that 37 like coffee, so out of that 61, 37 of them are women, so the probability of selecting one of those people is 37 out of the 61. And we have prime numbers here, so we cannot simplify. In question 18, we are being told that Food Mart and Jan's store sell boxes of the same type of breakfast cereal, but each store has a special offer. Food Mart then are selling a 400-gram pack, and they are offering 20% off the normal price of £5. In Jan's store, the actual size of the package is being increased. It was 400 grams, but it's now being increased by 30%. The price, however, is staying at £5. We need to know which box of cereal is better value for money and show our working. Okay, we need to know just how much we are getting for our money here. So let's have a look at the effects of the two offers. If we look first of all at Food Mart, we are looking at a price of £5, but there's 20% off. Now, taking into mind that £5 is the original 100%, taking 20% off means we are actually only going to be paying the other 80%. So we need to find 80% of £5. A few ways you could do this. What I normally do is take the £5, the 100%, I divide it by 100 to find 1%, and then multiply by 80 to find 80%. In this case, we come up with an answer of £4. So the offer at Food Mart is that you are getting 400 grams and it is costing you £4. Let's move on for a moment to Jan's store. Now, Jan's store, we know the price is going to remain at £5, but we're getting more of the cereal. So we're starting at 400, and again, I would usually use the similar method. 400 is 100% of the original. I will then divide that by 100 to find 1%, and then multiply by 30 to find 30%. And the answer I get here is 120 grams. This is the increase. Don't forget, in this case, I need to add this to the original 400. So I'm now getting 520 grams. So to compare the two, we now have 520 grams for £5. Now we need to have a look at which of these is actually giving us the better value. The way we do this, well, if you consider Food Mart, we are getting 400 grams for £4. So if I take that 400 and I divide it by 4, that's telling me how much I'm going to get for every £1 spent. And the answer in this case is 100 grams. So 100 grams for £1. If I do a similar exercise here, I'm getting 520 grams for £5, so I divide that by 5, and again it tells me how much I'm going to get per pound. In this case, 104 grams. We can now do a direct comparison. Food Mart are offering me 100 grams for every £1 I'm going to spend. Jan's Store are offering me 104 grams, so Jan's Store is the better deal. Question 19. Rotate shape A 180 degrees about 10. So we're looking at a rotation, we're going to turn it round. 180 degrees, well that's half a circle. So if we look at the graph in total, if we're going to move from this quadrant to this quadrant, that is 90 degrees. This quadrant then is 180. So we're going to rotate the shape 180 degrees. It will end up in this bottom right hand quadrant somewhere. We're told we're not rotating it around the middle of the graph, but at a specific point, which is 10. So it's worth marking 10 there. That is the center of our rotation. Now the way we do this is to look at points on the original shape. Let's look at this bottom corner here. If we make our way from the point of rotation 10 and we go up 1, 2, 3 and then we go left 1, 2, 3. So to rotate we're going to do exactly the opposite to create 180. So we're going to go down 1, 2, 3 and right 1, 2, 3. Therefore the bottom corner is going to be the top corner on this side. Don't forget it's being rotated, and it's going to go there. Let's pick another point. Let's pick this point at the top right hand corner. This is 5 up and 3 back, so we're going to go 5 down and 3 back, and we end up here. The top left hand corner from our point of rotation is 5 up and 1, 2, 3, 4 back. So we're going to go 1, 2, 3, 4, 5 down and 1, 2, 3, 4 to the right. You can see the shape taking place. Let's just check the final corner, which is here. This one from point of rotation is 4 up and 1, 2, 3, 4 left. So we're going to go 1, 2, 3, 4 down and 1, 2, 3, 4 right. We've now plotted all 4 corners of the shape. Therefore, if we complete it, it is going to be like this. We have now rotated it 180 around the point that we were given. Question 20. Work out the value of 3 to the power 7 times 3 to the power minus 2 divided by 3 to the power 3. Well, we're looking at laws of indices here. So let's look at the top line of this equation first. We have 3 to the power 7 times 3 to the minus 2. When we are multiplying the same number with different powers, the laws of indices said we add the powers together. So the top line can be rewritten 3 to the power 7 plus minus 2. We combine the powers. 7 plus minus 2 is 3 to the power 5. We can then look at adding the bottom part of the equation. Now this time, rather than multiplying, we are dividing. Therefore, as we are dividing, we are performing the opposite function. And again, laws of indices says when we divide, we subtract the powers. So actually we are now looking at 3 to the power 5 minus 3. Therefore, 5 minus 3 is 3 squared, and 3 squared equals 9. Question 21, part A, we are given a formula. It says that v squared equals u squared plus 2as. And then we're given the values of u and a and s, and we are asked to work out v. So let's make a start. We are looking for v. At the moment we are told we have v squared in the formula. Equals u squared. Well, u squared is 12 squared. So let's just write that in for the moment. U is 12, therefore it's 12 squared. Plus, we then have 2 times a times s. So that's 2 times a is minus 3 times s is 18. Let's sort this a little bit further. 12 squared is 12 times 12 is 144. Plus, we have 2 times minus 3, that is minus 6 times 18. And of course we're using BIDMAS, so we've got the next line is 144. Then we have minus 6 times 18. Well, that's 108. Don't forget, a minus times a plus is a minus. So minus 108. So we now have v squared equals 144 minus 108. The answer to that is then 36. If we're looking for v rather than v squared, then we need to find the square root. Therefore, v is the square root of 36. Therefore, v equals 6. The second part of question 21 is all about rearranging formula. It's giving us the same formula, but it's asking us to make S the subject. Now, of course, at the moment, V is the subject. So what we need to do is move everything away from the S to leave it on its own with everything else on the other side. This is a reverse BIDMAS situation where we do the pluses and minuses before we do the multiplies. So in fact, what I would do is take the v squared, and the first thing I would do is move the u squared across. Now at the moment it is u squared, therefore it is a positive. When it gets to the other side, it's going to be negative. So we have v squared minus u squared equals, and we still have 2as on this side. The next thing we need to do, well, we've got v squared minus u squared. We need to move the 2 and the a. It's all multiplied together here. So actually we can move the 2a all in one go. At the moment the 2a is being multiplied by the s. It's a multiply. Therefore we take it to the other side and it becomes a divide. So v squared minus u squared over 2a equals s. We have done that. If you want to make it look aesthetically better, you would write the s first. So s equals v squared minus u squared over 2a. In fact, either way around is a correct answer. Question 22, a long story on this one. A bonus of 2,100 is shared by 10 people who work for a company. 40% is shared equally between 3 managers. The rest is shared equally between 7 salesmen. One of the salesmen said, if that bonus was shared equally between all 10, I'll get 25% more money, and we need to prove whether he is correct or not. A little bit of work involved in this one, but it is a 5-mark question, so well worth the effort. Let's have a look at who is getting what. We've got a bonus of £2,100. Now we know that 40% of it is going to the managers. So if we want to find 40%, we would multiply it by 40 and divide by 100. Or the other way around, 2,100 divided by 100 times 40. That gives us 40%. In this case, that comes to £840. Now we don't need to know what each manager got individually, we can just leave that as a lump sum. The fact is, if they are taking 840, we need to subtract that from the total bonus to find the share for the salesman. So 2,100 minus 840 is £1,260. That is what the salesmen have got to share. There are 7 of them, so we now have 1,260 divided by 7. That means that each salesman gets £180. Now, we now know how much one of the salesmen is getting, £180. Now, he claims that if the money was shared by all 10 people, he would get 25% more. So let's work out what 25% more of this is. Well, 25% is a quarter. So if we divide that by 4, it means £45 is the extra amount he would get. So add that on to the 180. It means if he was to receive 25% more money, the total he would get is £225. Now let's look what actually would happen if the 2,100 were divided by 10 people. Then each of them would get £210. This is not as much as we've worked out for his 25% increase, therefore he is wrong. He's only going to get an extra £30 as opposed to the £45 he thinks he would be getting. Question 23. It would take 120 minutes to fill a swimming pool using water from 5 taps, and we're asked how many minutes would it take to fill the pool if only 3 of the taps were used. Well, the trick here is to find out how long it would take one tap. Now, if we know that 5 taps is 120 minutes, if only one of those taps were running, it would take 5 times longer. Therefore, 120 minutes times 5 means that one tap would take 600 minutes. Now that we know how long it takes one tap, we can say, okay, 600 minutes for one tap, but if I turn 3 taps on, that means it's only going to take a third of that time. So 600 divided by 3 equals 200 minutes. That's the answer to the first part of the question. Now part B says, state one assumption you made in working out your answer. I guess you could find 1 or 2, but the most obvious one is that all the taps in this question are running at the same speed. Question 24, a plane travels at a speed of 213 miles an hour, and part A wants us to work out an estimate for the number of seconds the plane takes to travel a mile. Now, what we have here is a speed, we have a distance, and we are looking for time. So actually we are looking at one of our triangles, which says that distance is speed multiplied by time. If we change that around, we have been asked for the time, so the time is distance divided by speed. So time is distance divided by speed. Let's look what we have here. The distance is a mile, so we have 1. The speed is 213 miles an hour, but let's just go back to the question. It's saying estimate. So let's keep things a little on the simple side for us. 213 as an estimate can be rounded down to 200. So what have we found out here? We found out that if we have a distance of a mile and we have a speed of 200 miles an hour, the number of hours it takes to travel a mile is 1 over 200, distance divided by speed. But this is in hours. The distance is in miles, the speed is in miles per hour, so the time is in hours. We've been asked for the number of seconds, so if we multiply this by 60, we get 60 over 200. And of course the reason we've multiplied it by 60 is because that takes us from hours to minutes. We still haven't gone far enough. We need to go to seconds, so we times it by 60 again, and we end up with our final answer of 3,600 over 200. Now that is our answer in seconds. Of course, as a fraction it makes no sense whatsoever, therefore we need to simplify that, and in fact 3,600 divided by 200 equals 18. So our answer is an estimate of 18 seconds. Now part B said, is your reason an underestimate or an overestimate? Actually, if you look at what we've done, we have used a speed of 200 miles an hour. The plane is actually going at 213 miles an hour, so the time is actually going to be a little bit lower. It's travelling faster, so actually hours is an overestimate because we have reduced or rounded down, put this in your own words, we have rounded down the speed and effectively slowed it down a little bit. Question 5 on this paper is a classic simultaneous equation question where we are given two equations and we are asked to find the values of x and y. We can approach this a couple of different ways, but our main aim is to eliminate one of the variables, one of the letters. We need to get rid of the x's or the y's. We can do this by multiplying the equations, adding them together, taking them away. The way I'm going to do it is I am going to get rid of the y's. So first of all, I'm going to call this equation 1 and I'm going to call the bottom one equation 2, just so that I can show the examiner exactly what I'm doing. Because the first thing I'm going to do is I'm going to take equation 1 and I'm going to multiply it by 3. So each of the terms in equation 1 need to be multiplied by 3 to keep things equal. So we have 5x times 3. I've now got 15x plus y, well, y times 3 must become 3y, equals 21 times 3 is 63. I'm going to call this equation 3. The next thing I'm going to do is I'm going to take equation 2 and I'm going to add it to equation 3. You'll see why in a second. So we are adding 2 and 3. So we have 15x plus another x up here, means we have 16x. We then add the y's together. We have a plus 3y and a minus 3y. Well, 3 minus 3 is nothing. Therefore, I've achieved my aim. I have eliminated the y. Add the numbers together on the end. 63 plus 9 is 72. So 16x is 72. Using your preferred method, either moving the 16 to the other side or dividing both sides by 16, you come up with the same answer. X is 72 over 16, therefore x equals 4.5. That's our first aim achieved. We've found the answer to x. We now need to find y, and we do that by going back to one of our equations and substituting the value of x. You can do it to any of the three equations that we've got here, but because y is on its own in this top equation, I am going to substitute into 1. So I've got 5 times x, so I know that is 5 times 4.5, which gives us 22.5. Plus y equals 21. Y is therefore equal to 21 minus 22.5. Therefore y is equal to minus 1.5. And that is the answer to y. You could have done this other ways. You could, for instance, have multiplied the equation 2 there by 5. So you'd had 5x on both and taken one away from the other. There are options. This is simply the way that I choose to do it. Moving on to question 26, and this certainly is the most complex question so far in this paper. We really need to have an understanding of what we're looking at here. So the diagram shows a square ABCD with sides of length 20 centimeters. So okay, here we have a square. It also shows a semicircle. We can see the white area at the bottom here, and an arc of a circle. So this is the arc curving from A to C. We're then given some information. It says AB is the diameter of the semicircle. Okay, so AB quite clearly is the diameter. This, in other words, is half a circle. AC is an arc of a circle with centre B. So in effect, this curve here from A to C is part of a circle, and the centre of that circle is at B. In other words, it's a quarter of a circle, because we know B is 90 degrees within the square. It says show that area of shaded region divided by the area of the square equals pi over 8. Okay, there are several things we need to do here. First of all, we know the area of the square. We know that the area of the square is 20 centimetres times 20. Therefore, it's 400. So we have the bottom part of our little formula here, 400. Let's have a look at the shaded region. Remember what we have. We have a quarter of a circle, and within that we have a half a circle. So to find the area of the shaded region, we need to find the area of the quarter circle and take away the area of the half circle. So let's have a look at the larger circle. If B is at the centre and A and C are on the outer edges, then the radius of this circle is 20. So if we use the formula pi r squared, that's going to be pi times 20 squared. But of course it's only a quarter of a circle, so we're going to have to divide that by 4. So we end up with, well, 20 squared, again, that is 400, times pi divided by 4. We can simplify that because, of course, 400 divided by 4 is 100 pi. So that is the area of the quarter circle as described by the arc AC. But we have to take away the smaller circle. So let's have a look at that one. We know it's a half a circle. We know the diameter is 20. So in this case, the radius is 10. So again, if we use pi r squared, this time it's pi times 10 squared. Now this time, because it's half a circle, we're going to have to divide that by 2. So we end up with, well, 10 squared is 100 times pi divided by 2. And again, let's simplify that. The area of the smaller circle is 50 times pi. 100 divided by 2 is 50. So we now need to take the smaller circle away from the larger circle. So that's going to be 100 pi minus 50 pi. 100 minus 50 is 50 pi. So we are saying that the area shaded in grey is 50 pi. We have to show that, look at the formula here, the area of the shaded region, 50 pi, divided by the area of the square, which we know from up here is 400. We have to show that that is pi over 8. Well, if we simplify 50 and 400, we get 1 and 8. This does indeed simplify down to pi over 8. Question 27. Amina has 2 bags. In the first bag there are 3 red balls and 7 green balls. In the second bag there are 5 red balls and 4 green balls. Amina takes at random a ball from the first bag, first diagram, first part of the diagram here. She then takes a random ball from the second bag. So part A is asking us to complete the probability tree diagram. Okay, let's have a look at the first bag. There are 10 balls altogether, 3 plus 7. So as has already been completed for us, if there are 3 red balls out of the 10, the chances of choosing a red ball are 3 out of 10. That means the other 7 balls are green, so the chances of pulling a green ball are 7 out of 10. In the second bag we are told there are 5 red and 4 green, so there are 9 in this bag. We can see this here. The chances of taking a red ball are 5 out of 9. Therefore the chances of taking a green ball are the other 4 out of 9. And in the second part of the probability, well, the odds are exactly the same. It's the same bag. So once again we have 5 out of 9 chances of taking a red one and 4 out of 9 are taking the green one. So that is the probability tree complete. We're now asked in part B, work out the probability that Amina takes 2 red balls. So in other words, the route that she's taking is a red ball here on first choice. Well, we know that to be 3 out of 10. When she's done that, she puts her hand in the second bag and also gets a red ball. And again, we know the probability of that is 5 out of 9. The way we combine 2 probabilities is to multiply them together. So the answer is 15 over 90. That's a good answer in itself. You can, if you wish, simplify that. Question 28 tells us the side of each interior angle of a regular polygon is 11 times the size of each exterior angle. Work out how many sides the polygon has. There are a couple of ways you can approach this, but if you consider, let's just draw a slight sketch of a corner of a polygon. If you use the rule that the interior angle here plus the exterior angle here total 180 degrees. That is true whatever the polygon. Now, using that information, let's call the external angle, let's call that x. That means that the internal angle is 11 times bigger, so the internal angle is 11x. So the external and the internal added together, that means we have 12x. Using the knowledge that the external and internal always add up to 180 degrees, that means that 12x equals 180. If we divide both sides by 12, it means that x equals 15 degrees. Now don't forget, x is the external angle. So we now have a regular polygon where each external angle is 15 degrees. The other rule we use, of course, is that the total of all external angles, and this is true again for any polygon, the total of the external angles always adds up to 360 degrees. Using this rule then, if we have 360 degrees in total of the external angles, we know that one of them is 15 degrees, so if we divide that by 15, it means there must be 24 angles. Therefore, there are 24 sides. If you have found this video useful, please do check out the rest of my channel. I have other similar papers which I've covered in exactly the same way, and I will continue to release new ones as they become available. Thank you very much.